We did it. We are officially done with the complex world of static fields and potential in Unit 10. I am your physics buddy, and today we are taking those stationary charges and putting them to work as we move into Unit 11 electric circuits. This is where physics gets real. In the first lecture, we are diving deep straight into the heart of circuit analysis, resistors. We aren't just looking at Ohm's law, we are mastering the logic behind series and parallel combination, and how to simplify even the messiest network into a single equivalent resistance. If you're feeling a bit shaky on how potential difference or voltage works, remember that our entire 9 lecture series on Unit 10 is already live on the channel. I highly recommend a quick review to those sessions
So
to
let's
make
start
sure your circuit math
about this
stays
particular
sharp.
chapter,
Make sure
which
you are
is
subscribed
referred as
so you
basic
don't miss
electric
a single
circuits.
step in this new unit.
So
Grab your
basic electric
calculators,
circuits
let's start wiring these circuits
involves
up.
use of so many components. So first of all, we have to understand about those components. Apart from that, we need to understand that how those components can be resolved in the given circuit. So if we try to define what basic electric circuit is, so those circuits which has a combination of a resistance in it, which might have a combination of capacitors, and later on we also going to talk about combination of inductors. Apart from this, a battery, switch, or any other component like bulb or something. So when these things came together, they form a basic electric circuit. Before moving into a specific one, whatever we have done in this class, whatever we have done in the last class, let's try to revise that thing because this is going to play a key role here. So in the last class, we talked about that whatever potential difference is there across any conductor, it is directly proportional to the current which is being flown in the current circuit. So when we remove this proportionality, we got a constant known as R, where R is supposed to be called the resistance. Then we talked about that this resistance must have some value in different combinations. So in series combination, it is supposed to be the sum of the values of resistance, which will give us the value of net resistance in series. Whereas in parallel combination, the result was a little different. So 1 upon R net in parallel combination must be equals to 1 upon R1 plus 1 upon R2. So we have to keep these relations in mind before actually heading into the session. So in this particular lesson, we are going to talk about following things. First, we're going to understand that how resistance in series and parallel combination is going to be solved. Then we'll talk about Kirchhoff's law. This is the most important law you'll learn here. Like this, you must have like a little bit of idea about this law. You must have learned it in class. Did you?
Yeah,
So understanding that how the equation of a given loop is being written is basically given by this Kirchhoff's law, and this is very, very, very important. There will be definitely one FRQ from this particular topic, so we have to keep that in mind. Apart from this, we'll talk about some special type of circuits, and here we are going to talk about RC circuit. Now, what this RC circuit means? RC circuit means basically a circuit which contains two components. One component is resistance, and other is capacitor. So this is a special type of circuit also that we have to talk about. Let's talk about combination of resistance. Let's start with a simple problem. Problem says that there are resistance connected in a circuit like that. There is a battery of 10 volts potential having resistance 5 ohm here, 10 ohms here, 15 ohms here. Question is very simple, find current. Can you try this?
okay.
First,
10 amperes.
how you got 10? Explain.
So those two are parallel. So you, I think, add them and then
No, they are
divide
in
them
parallel
by
combination.
15.
We have to
Hmm?
use this.
Okay.
Oh, so you said basically you have to add them and divide them by 15.
Yeah.
No, you have to apply this particular relation. So when you
Okay.
apply this, you got
15 plus 1
1
over
upon
10
R is
plus 1 over 5.
yes. So now you can get the value. So it is coming out to be 10 over 3. This is going to be
Okay.
the value of resistance. Now, this
10 over
resistance
3
is
over
in
10.
parallel with this. This resistance, 10 over 3 is in series with 15 ohms. So now you can simply add them. So when you
Yeah.
simply add them, it
So,
is over 10 over 3 plus 15. So 10 plus 45 over 3. That is 55 over 3. So this is the value of resistance. Now we
okay.
simply apply Ohm's law. Ohm's law says V is equals to IR. So I must be equals to V by R. That is V is 10 and R is 55 by 3. Current is going to be 30 by 55 or 6 by 11 amperes. So this is how you are supposed to solve this particular problem. First of all, you have to find the resistance, net resistance in whatever circuit we have. Then simply apply Ohm's law, which says V is equals to IR. You must have two things. Either you need to have resistance or current, or you can say potential. Let us move to another problem. This might help you to understand the concept little well. So this is the combination. The value of resistances are all values are same. So you have to find the net resistance between point A and B. Try it out and tell me.
2, 1 over R plus 1 over R plus R.
You need to tell the whole answer, not an equation. So if we solve this, the net resistance is going to be R by 2. This is
Okay.
R itself. Again, this will give us R by 2. When we simply add all of them, we are going to have 2R as the net value. So this is the net resistance. So you just have to figure it out that how much resistance is being there in given place.
Okay.
So this is the circuit now. Again, the question is almost same. You have to find the net resistance, assuming the value of all the resistors to be R. Find RAB, resistance between point A and point B. Try it out.
2R.
How did you do it?
So one is in parallel and the other 4 are in series.
No, you have to see the flow of current in order to understand which thing is in parallel and which thing is in resistance. In order to do this, let's mark the resistors. 1, 2, 3, 4, 5. Now try to understand how current is being flowing. At this particular point, current have three ways to go. So how will it go? It will split into three parts. I can say I1, I can say I2, I can say I3. Now these three values of current will again change if there is another break, or you can say another diversion. So I1 will going, so first resistance will experience current I1. Now I1 will keep going. The second resistor I1 will face, or resistors which face I1 current is going to be second. So 1 and 2 are in series because they are getting same current. Now I2. So this R third resistance is getting I2 current. Similarly, I4 is getting something else. It is getting combination of I1 plus I2. Now now this fourth resistor is getting I1 plus I2 whereas this fifth resistor is getting I3. So everyone is getting almost different current, so they are not in series, neither in parallel combination. Now what we have to do is we have to start resolving them one by one. So just assume these are the 2 points A and B. Now as I told you, these two are in series. So series combination of the two resistors will be R plus R, that is 2R. So now this will become 2R. This is R as usual, and this is also R as usual. This is also R as usual. So we have just solved this combination and we got 2R here. I hope this is making sense now.
Yeah.
Now these two resistors, how we can identify whether they are parallel or not. So now current, imagine it is dividing into three lines as usual, I1, I2, I3. So as we know that this particular wire has only one resistor and it is experiencing I1 current, and similarly this wire has one resistor experiencing I2 current. So these two must be in parallel because once they meet again, they become I1 plus I2 as the sum was there initially when it started getting into it. So these are in parallel combination. So in parallel combination, we can say 1 upon R net is equals to 1 upon 2R plus 1 upon R. So it is going to be 2R 1 plus 2. That is 3 by 2R. So R is going to be 2R by 3, reciprocal of it. So we got again some change in the circuit. So apart from these two, I'll be drawing only one and one like that. And this is going to be what? This is going to be 2R by 3. This one was R, this one was R. Now again, current will divide into two parts, I1 and I2. Now try to understand the same concept again. This I1 is going through these two resistors once again. So these two must be in series. Now series combination. So R net of these two is going to be 2R by 3 plus R. That is 2R plus 3R by 3. That is 5R by 3. So now the value of resistance has changed to what? 5R by 3. Now the same thing will be done. This is point A, this is point B, the final step. This resistor, now it is connected here, is going to be 5R by 3. And this is R. Once again, we have to solve the parallel combination in order to get 1 over RB, which is going to be 1 upon 5R upon 3 plus 1 upon R. Once we solve this, we got the answer. So the answer is going to be 5R 3 plus 5. So 5R by 8 is going to be the value of RAB. Did you understand? Did you got this whole part?
Yeah.
Yeah, these are some of easy questions based on series and parallel combination. Let us move to something new, something different. So next question is like that. Suppose there are three resistors connected in parallel combination. And this is whole thing is connected to a battery. The battery is of 20 volts and the resistors are of 10 ohms each. No, the above two are of 10 ohms and the below one is of 15 ohms. So the question is, find the value of current passing through each branch. If you did this, it means you got the concept. Try to do it. Think about each and everything we have discussed so far about series combination, about parallel combination, about solving current. Think about each and every aspect. So now what are the properties of the parallel combination we have discussed? Think about that. Think about that. In parallel combination, we studied that the potential remains same. Potential doesn't change, whereas the current divides. So that is the property of the parallel combination that you need to keep in mind. So here the potential between all the resistors must be is 20 volts. So
Okay.
here we can say that I1 into 10 must be equals to 20. I2 into 10 must be equals to 20. I3 into 15 must be equals to 20. As it is a parallel combination, potential must be same across all resistors. So from here we can say I1 must be equals to 2. That is 2 amperes. I2 must be equals to 2 amperes and I3 must be equals to 4 over 3 amperes. Now sum of these current must make the current which is coming out through Ohm's law. So we are going to have here 6 plus 6 plus 4, that is
75 amperes.
14 over 3. 14 over 3 amperes. So it is going to be roughly around 4.67 amperes. Now let us try to find out the same using Ohm's law and let's see whether it is coming same or not. So from Ohm's law, it should be I into R net. So current should be V over R net. So if we have to find the net resistance, it is going to be what? 1 over 10 plus 1 over 10 plus 1 over 15.
4 over 15.
4 over 15, it should be 15 over 4,
No, 4 over 15.
which is coming out to be 30. 3 plus 3 plus 2. So again, it is coming out to be 8 over 30. That is 30 over 8 is R net because we have to reciprocate it.
Okay.
15 over 4, that is going to be the answer. So 15 over 4 and potential is 20 volts. So once we solve this, we got 4 into 4 by 3. That is 16 over 3. There is some variation. It should not be here. Resistance is 15 over 4. That's fine. V net is 24 over 3. 16 over 3. 16 over 3 is also coming out to be, it is coming out to be 5.1, 5.3 P amperes. This is a lot of difference. That much difference should not be there. Let's try to verify whether some calculation has been made wrong or not. So I1 is going to be 22, I2 is going to be 22, it is going to be 4 by 3. Some of these current will constitute I, that is the net current coming out of the battery. So this I must be equal to the sum of these three currents, which is 2 plus 2 plus 4 by 3. So 2, 6 plus 6, it is going to be 12. Okay, that is not wrong. This is wrong. This should be 16. So value is similar in both the cases. So whatever values we have got is correct. Did you understand?
Yeah.
Let's do some more problems based upon it only. So suppose there is a circuit. And the potential between the component or the point, maximum potential difference between the points is 20 volts. This is 5 ohms, this is 10 ohms, this is 20 ohms. Question is find current through 20 ohm resistor. That good. You have to find the current over 20 ohm resistor. If we don't consider any resistance here,
Okay.
the current is going to be whatever potential this point has.
So
So
20
as we,
volts?
yeah, so potential is going to be 20 volts if there is no external resistance connected. So we can simply apply Ohm's law and we can write that I is going to be 20 over 20. That is 1 ampere. So the current from this passing through this 20 ohm resistor must be 1. But what if there is some resistance? Let's say 40 ohms. Now what? What is going to be the current through this 20 ohm resistor? Now this becomes a very tough question. Apart from the previous one, it becomes a very tough one. So how we are supposed to solve this? Let us try to understand it. Learn the each step carefully. So if the question says that these 2 points has some potential across it, what you can do is just try to draw the same through the diagram. Represent the same through the diagram by connecting a battery like that. So now you got the idea the battery has the potential of 20 volts as said by the question. Whereas the resistance has value 5, 10, 50, 20, 40. Now what we know is that if we consider these three, so these three must be in parallel combination. So as these three are in parallel combination, so we can solve them first because without solving them, we cannot find out what is the current through this particular branch we have. So we solve this. So 1 over R must be equals to 1 over 5 plus 1 over 10 plus 1 over 10. Sorry, 20. So we solve this. We got 4 plus 2 plus 1. So R is going to be 20 over 7. Let's keep it that way only. The R here we got in place of 3 resistors is 20 over 7. Whereas this resistor is supposed to be 40 ohms, it stays here as well. Now we understood that we have two resistors connected. One is of 20 over 7 and another is of 40 ohms. So if we try to find out the value of current, we can easily do. But do we need it? Uh, I must say that yes, we do need because we have to find out what is the potential across this particular section. Because this particular section's potential is important, that is we have to find. Because if we got this, we can simply multiply the same with the 20 ohm resistor, and this is going to be the current. So potential will help us to find the value of current. How we can do this? By simply finding out the value of current. So I is going to be V by R from Ohm's law only. That is going to be 20 over. What is the R net? As these two are in series, so the R net is going to be 20 over 7 plus 40, which is 20 plus 280 over 7, 300 over 7. So 300 over 7. So this gives us the value of 7 by 15 amperes only. We got the value 7 by 15 amperes. We can find out potential. That is this value of V1. V1 is going to be IR. I is 7 by 15. R is 20 by 7. 7 by 15. It is coming out to be 4 by 3 volts. So now we got the value of potential across this particular section, which is 4 by 3 volts. As it is only 4 by 3 volts, in order to find out the value of current across this, it is going to be V over R. So I is coming out to be V over R. V is 4 by 3. R is 20 amperes. So it is going to be 4 over 20 into 3. So this will give us the value as 1 over 15 amperes only. Like this much small value of current must be passing through this much value of resistor. So again, the process to understand that how everything works, it is important. If you got this particular question, we got most of this particular topic like combination of series and parallel. So does this make sense?
Yes, sir.
All right, let's do one more problem. Try to solve it. So the question is somewhat like this. This is my A point, this is my B point.
Okay.
Each and every resistor is having a value R. You have to find once again REB. Try it out and tell me what it should be.
Okay. I'm getting 4R plus R by 2. That's 1
4R
over.
plus R by 2. Uh, I don't think so, I guess. Let us try to solve this. So we have to find resistance between A and B point. So again, you can just draw the current through the wires and see how the current breaks. This will also let you understand that how what resistance is in which combination with which other resistance. So here you can see that there is no break. So these two resistance will be series. So it is going to be 2R. So this resistance is in combination with this small r, with this r. This 2R and R is in parallel combination. So we can solve this. And we are going to have, you can say 2R 1 plus 2, that is 3 by 2R. So the net is going to be 2R by 3. Now this 2R by 3 is in series with this R. So this 2 will be in series. So we'll get R plus 2R by 3. That is going to be 5R by 3. Now, I guess you must have understood what exactly we have done. So here, now what we got is that there is only one resistor which is of 5R by 3 resistance. Apart from this remains the same. Now as you can see again, these two are in parallel combination. So 1 over R plus 5R over 3. If we take the LCM, we'll have 5 plus 3. So 1 by R net must be equals to 8 by 5R. So R net is coming out to be 5R by 8, like that. So now we got the value of these two resistances, that is 5R by 8. So the final look of the circuit must be like that. This is R, this is 5R by 8, this is again R. Now which combination is this? How can we find R net here? Assuming these three. Are you there?
In RNet should be two are in parallel. No, two are in series, and plus 8 over 5 are.
No, the current is passing same through each resistors.
Okay,
So they must be in series.
all
And if
should
they
be
are
in
in
series.
series,
Okay,
we just have to add them. That's it.
okay,
If it is in parallel, current should divide. But if the current is not dividing, it means it is in series combination. So whole thing should be written that way only by considering all of them in series. So we got
okay.
approximately 16 plus 5, that is 21 R by 8. This is the answer to this question. I hope you understood this particular section as well.
Yeah, I understood most of it. Yeah.
So what you can do is later on as well, that if you are going through this particular topic again, so just go through with the recording. You must have seen it.
Okay,
So I'll
okay,
try to keep it updated. Maybe let's say once a week at least. But yeah, you can do that on book, which we're supposed to follow. And I would say that you should try this particular section now from the book. You can mark the questions.
okay,
It's 18.1 section. There are different values. There are different terms as well which have been used here. But what you can do is just go through with it. If you didn't understand, just let me know. But make sure you try these questions today only so that before the next class, that is tomorrow, we have something to discuss on your learnings.
okay,
So make sure you try these 8 questions, and tomorrow I'll give you the next part with whatever we have to do. And anything if it is there, we'll definitely discuss. So make sure you do that.
okay.
All right then, let's keep it till here only. See you tomorrow, same time.